It's time to make a decision again, and it's time to make a coin flip again. So let's do it. And we're gonna start with the NeoGo department again. This time, I don't know, maybe it's the wrong coin, maybe it's something, but it wins again. In December, we have released a new NeoGo version 0.107.2, and it's mostly a maintenance release that contains some bug fixes, but at the same time it introduces a new configuration option for your nodes. It's still an experimental one, it's not expected to be used a lot currently, but it improves our ability to cut the blockchain tail. Like NeoGo is known for its ability to drop old blocks that are currently unused or untraceable to be more correct from the current transactions and blocks. So now we can remove headers along with blocks. For a long time, it was considered to be not really correct to drop headers from the chain because it was still required for synchronization. But right now, as we are progressing with our NeoFS based or block storage in NeoFS based basically approach, we are considering headers are as no longer needed for successful synchronization. At least it's not required for nodes, that is the blockchain nodes, to store these headers. You can always fetch them from NeoFS, so that makes them pretty much useless for nodes. And for a long-running networks that had a million of blocks, it's really improving the storage requirements, because currently we are able, for example, to feed our testnet networks that are using these options, these experimental options now, into just 1.5 gigabytes per database, and these networks have some millions of blocks already. So it's a good improvement, but still it's considered to be experimental, so be careful. And maybe for mainnet and testnet public networks it's not really appropriate, but for NeoFS it works great. We are planning to release a NeoGo 0.108.0 pretty soon in February. It will bring garbage collection improvements that are already implemented and also some RPC extensions that are also already implemented, and also RPC binding generator improvements, because we currently are able to produce more code that is useful for contracts, or mostly backend code that invokes contracts. So this support code will be released with the 0.108.0. Also, currently we are moving on to our snapshot synchronization mechanism that we are developing. A part of it, the header fetching, is already implemented in the queue in the PR and is going to be a part of this new release. But this is just a part of it and is basically a preparatory step, but we need to now make a mechanism to store these snapshots and fetch them and use them for synchronization. We have already played with some components of it and we expect it to be relatively simple, but at the same time, probably it will keep us busy for the next 2 months. This may look like a very minor release for dBFT library that we provide, because it's just a patch version, it's just a few lines in the changelog, and actually not a lot of lines of code really changed. But at the same time, it really is important, and I want to tell you about it. Because it started from the issue that was submitted more than 3 years ago. It was just an idea of how can we make the dBFT block time, the interval that we have between blocks, to be closer to the target one. We have already done some improvements on the node side for this to happen, but we also knew of some other sources of these inaccuracies that we have. And the idea was submitted, as I have said, years ago, and we actually had implemented it because the results that we got from tests back then were somewhat mixed. In some areas, it was a clear improvement. The block time metrics were clearly improved and it was all perfect. But at the same time, we had some degradation in the TPS metrics. And also there was some behavior that we could not explain really back then. At least we thought that, okay, it's an improvement, but it's not worth spending much more time on it. At least for now, because as usual, we have a lot of things to do. So it was postponed. It's basically stayed there in the PR for these years until we had another issue that we wanted to solve. It actually comes from our desire to have lower block times in neo-fast networks. As I have already explained in previous episode, we want to have 1 second block time for mainnet and testnet. So what we did in the end of December last year is that we have reconfigured our testnet to use 1 second block time. What we have discovered is that the actual block time is 1.7, 1.8 seconds. It's far from being 1 second, 1 perfect second. So we thought, okay, can we do something? And that's where this old PR, this old issue came, to life again, and we have rebased it, we have, already retested it, and actually found some explanations for the behavior that we saw, and we thought that, okay, it's acceptable, it's a really nice change overall, especially given that now it works better than previously, so it was accepted. But it was not enough, because although it clearly has cut off some milliseconds, some hundreds of milliseconds I would say, it was still not enough to have perfect, or at least closer to perfect time for this testnet network. And I need to tell you about this testnet network a bit more, because it has 7 consensus nodes, just like mainnet, the Neo N3 mainnet, but these nodes are scattered all over the globe. It's 6 countries for these 7 nodes, ranging from Canada to Singapore, with all of the stops in the middle, no matter what way you go. Like, there is a node in Australia, actually, and in Great Britain as well, so it's a pretty diverse network. And the ping time we have in this network between these nodes is around 200-300 milliseconds, which is a normal number for internet connection that we have, and especially given the fact that these nodes are not good machines. These are really dirt cheap virtual machines. Remember that it's still testnet. It's not supposed to have a lot of resources. So we are trying to have a 1 second block with the ping, basically the round trip time of 200-300 milliseconds. If you are to look at the retrospective, it's not surprising that we got 1.7 and 1.8 initially, because, if it takes 200 milliseconds for packet to travel from one node to another, then, well, what are we going to do? If we have dBFT with its several rounds of communication. So we decided to put a bit more effort into it, and I actually remembered of one of the old discussions that we had in the Neo repository about block time and how can we make it better. And we also knew of the source of this inaccuracy, but at the same time we thought that it's not really possible to solve it without some additional data, like in-block data or in-protocol data. And these solutions were not really acceptable to me, at least, because relying on these data, additional protocol data, is not really good for dBFT. dBFT has always relied on local timer only for any time-related decisions, and we thought that it's important to keep this property no matter how we optimize the protocol. So that's when we thought that, okay, we have local timer only, what can we do with it? And actually we have found some way to leverage it and to try to estimate what network delays we have and adjust timer by it. It works surprisingly well. If you want to summarize what we have achieved in one picture, it's gonna be this. If it looks a bit more hairy for you than you would like to, because it contains a sample of 1000 blocks from this testnet network, well, we can change it to this, because this one has just 100 blocks. And it's basically before and after. And we were able to achieve less than 5% deviation of the block time in a network that has a round trip time of 20-30% of the same block time, which I think is pretty much remarkable. This updated dBFT library is going to be a part of NeoGo 0.108.0, and of course it's also going to be used by the next NeoX release. So we are expecting some real improvements in this area in subsequent releases. Moving on to NeoFS, we have made 2 releases of NeoFS in December, 0.44.1 and 0.44.2. Basically, it's the latest and greatest of NeoFS, and there are not a lot of changes there compared to 0.44.0, because it was just some fixes for migration and things like that. So if you're using NeoFS, of course, grab the latest and greatest. But while using the latest and greatest of NeoFS known to the date, keep in mind that we are going to release a new version in February, and it's expected to be somewhere in the middle or maybe end of February, not very early, but at the same time we are going to have some important changes there. We already have in the queue improvements to the inner ring setting management that I have announced previously, and we also have in the queue some simplifications for write caching. Of course, some fixes as usual, nothing new there, but the main thing that we are going to release with this new version is the new search API that is going to be provided by nodes, and of course we are going to be then exposing it via the REST interface, via the REST gateway, but that's once we have a proper node with this new API. The API itself is explained in this PR, and I just want to reiterate some motivational part for it, because we already have some search API in NeoFS, but we have a lot of problems with it. The primary problem that we have there is just impossible to list objects in a container that has, some millions of objects. Like our containers that store NeoGo, or basically NeoN3, blocks. When we got some millions of them, like for the mainnet network that has around, 6, 7, whatever it is now, millions of blocks, we cannot enumerate them easily. We cannot search for them easily. And if your machine has enough resources, if you are patient enough to wait for these results to come, then yeah, of course, this can be done. But it takes so much resources, it's so time consuming that it's not just practical. It's not practical for real use. So what we are going to provide with the new API is, first of all, some limitations to the number of results that you can get. Second is sorting, because it's important. Otherwise, you can continue your search. And what we also will provide with this new API is additional capabilities dealing with attributes, because many applications like S3 Gateway or REST Gateway, they're not just doing some search, but they also need data from header, from block header, like they got some OIDs, but okay, they're not ready to do something with them. They need some additional data to make decisions, especially the S3 gateway. So to be able to really provide the service for you, they do some header fetching additionally to the search. So it looks like they do some search first and then fetch headers for blocks that they have got OIDs from this search. So it's not really fast, because if you're doing additional queries to NeoFS, no matter how fast NeoFS is, it's additional queries. And most of the time what they need is just 1-2 attributes from blocks that they want to make, some use of. Like timestamps, when this object was created, to be able to differentiate different versions of blocks, for example. So with the new search API, applications are going to be able to fetch some additional header data right in the same search request. It's all going to be provided with the same API. We already have some drafts for this API in PRs, but it's still work in progress. We will test it, of course, and there may be some minor changes, but we expect it to be a really important change for NeoFS overall. so important that we are going to phase out the original search eventually. We don't have a specific schedule for it or a specific, plan for it right now. It depends on how our components are going to migrate to this new search, but eventually I think this will happen. But for now, let's wait for this new release and this new capability. If you're using our wonderful action to upload artifacts into NeoFS and you're experiencing some problems with Python 3.12 that is currently being used by some GitHub runners, go grab this new release of the action. It fixes the problem. S3 Gateway went through a number of releases actually, starting with 0.33.0 that has disabled ACLs by default, just like Amazon itself did some year and a bit more ago. And also it fixed another multi-part upload scenario. Then it was followed by 0.34.0 that has fixed pre-signed URL problems that we had. And it was recently followed by 0.34.1, which is the latest and greatest at the time, that fixes some problems with copy object API. All of these releases and fixes basically follow our intent and our attempts to use S3 Gateway with real applications, because no matter how we test it with some, test suites for S3 that have, 100, 200, 300 tests, whatever, that poke around these copy objects, put objects, whatever API they test, they're all green and shiny, everything is fine, but then you put some real application to use this S3 gateway and it all breaks. And probably the most annoying thing here is that sometimes it doesn't break immediately. Like, it pretends to be working fine, this new application that you try to use. It works for a week or two, or maybe, for some scenarios, and you think that, whoa, everything is fine, and then suddenly, bam, it doesn't. So we are fixing these bugs, of course, because we want real applications to be usable with the S3 gateway. And actually, we are also putting quite a lot of effort in S3 gateway right now, and there will be more releases coming pretty soon. Currently, we are focused on removing some non-standard NeoFS extensions that S3 gateway currently uses, and currently depends on these extensions. These extensions cannot be used on mainnet NeoFS network, so we are replacing them with different solutions. Some parts of this work are already merged, but more are yet to come. We even think that probably the next release is going to be some hybrid, where some parts of S3 gateway are still going to use the experimental NeoFS extension, the tree service that it uses now for some functions, and some functions are going to be migrated already to the tree-less scheme. Overall, expect quite a lot of updates in S3 in the near future.